So last couple of weeks we've been doing a couple of videos based on movie clips, used movie clips as hooks to talk about mathematics. And well, it has a look at my collection, and we've got a pretty big collection of mathematical movie clips. If you look on the web, we're actually looking after the mathematical movie database, me and a friend of mine, Marty Ross. Anyway, in this collection is another clip that, well, I kind of sorted out the maths behind it like 2 years ago, but then I forgot about it again, and I thought, well, let's just put it in a video, and then it's done, it's there. Next time I actually want to revive the stuff, it's going to be there. All right, so this is from a movie called Last Year at Marienbad. It's quite a famous movie. It's a pretty pretentious movie. I hate it anyway. But apart from the maths is really good. So there's a nice game in there, and let's just have a look at the clip, and then I'll start talking about it.
Connaissez un jeu auquel je gagne toujours.
Si vous ne pouvez pas perdre, ce n'est pas un jeu.
Je peux perdre, mais je gagne toujours.
Essayons.
Cela se joue à deux. Les cartes sont disposées comme ceci. Sept, 5, 3, 1. Chacun des joueurs ramasse des cartes, à tour de rôle, autant de cartes qu'il veut, à condition de n'en prendre que dans une seule rangée à chaque fois. Celui qui ramasse la dernière carte a perdu. Voulez-vous commencer ?
Okay, well, there's the mysterious guy here, and there's the clueless guy, and they're actually having a couple of games throughout the movie, and the clueless guy always loses. Well, yeah, always. Now, the game that they're playing here is called, well, it's a special version of a game called NIM. It's a very mathematical game, which has a very nice winning strategy, and it's actually the winning strategy that enables this guy here to win all the time. So I want to talk a little bit about this. So it's NIM, it's called NIM. One nice thing about NIM is that when you turn it upside down, it turns to win. So we'll call this video here NIM to win. Okay? So what's the setup? Well, we've got cards, 1, 3, 5, and 7. I've actually colored them in to make things even easier to refer to. Now, the winning strategy is based on binary representation of numbers. Okay, so at the moment we're kind of writing things down in decimals. We want to write things down in binaries, and that involves expressing numbers as sums of powers of 2. So in decimals we express them basically as sums of powers of 10, binary of 2. Okay, so with these numbers here, what powers are we talking about? Just 1, 2, and 4. Okay. So now to turn 7, for example, into binary, what we do is we'll first look, well, what's the largest of those numbers that goes in 7? It's the 4. So there's a 4. Then there's 3 left over. What's the largest power of 2 that goes in there? 2. And then there's just the 1 left over. And that makes this number then into 1, 1, 1. So 7 in binary is 1, 1, 1. What about 5? Well, largest of our numbers or powers of 2 that goes in there is 4. And then what's left over is 1 is already one of those numbers again. So that means that the binary, so 5 in binary is 1, 0, 1. What about 3? Well, 3 is 1, 1. And 1 is 1. Okay, so I mean, I could talk about binary numbers here, but I'm not going to. I'm just going to kind of draw these diagrams. And it's clear what I'm saying here, right? It's basically a special way of nicely representing binary numbers. Okay, so let's just save this somewhere up there. All right, so that's how the game starts. And well, maybe that was a bit quick, so let's just follow through what actually happens here in the game. All right, so this guy says, you start. Clueless guy, you start. So clueless guy is faced with this set up. And now what does he do? Well, he doesn't know what to do, so he just takes a card. All right. Now, mysterious guys, what does he do? Well, he also takes a card. At this point in time, we actually don't know whether he knows what he's doing or not, right? So who knows, right? Clueless guy, well, he just wants to know what's happening now, right? So what does he do? Well, he just takes away a lot of the cards, right? And maybe just to reiterate the rules, right? On every move, you can either take away just one card, or two cards, or three cards, or all the cards, but they have to all be from one row, right? That's very important, right? So you can't take away cards from different rows. Okay, that's what people are doing at the moment. All right, so he's just taking away all the cards here. He just wants to see what happens, okay? Now what does the mysterious guy do? He takes away 2 cards. All right, well, that seems like he knows what he's doing. Actually, you could start analyzing what's happening here. Let's just not do this. Let's just kind of keep going. What does the clueless guy do? This one here, mysterious guy, 2 cards. Okay, then it's all predetermined, right? Once you're down to 1 card each in every one of the rows, you basically just take turns taking off cards, and then just 1 card left over for the clueless guy to take. So mysterious guy wins. Okay, now what I'm going to do is I'm going to turn every one of those diagrams into one of my binary diagrams, okay? And I'll just do this in one go. Fancy. Okay. So, and now we'll have a look at, the different diagrams here. Now, this diagram is what I want to call balanced. Why is it balanced? Because if you look at the ones in here, there's an even number of ones, there's an even number of twos, and there's an even number of fours. Now, when you look at what the clueless guy is left with when he's finished, this diagram is actually unbalanced because you've got an odd number of ones. Well, that's balanced. The twos are balanced, the fours are balanced, doesn't matter. As long as one of the numbers that you see here is not balanced, the whole thing is not balanced, okay? That's not balanced. That's balanced again, right? So 2 here, even, even, even. Then down here, not balanced, right? There's just 1 here, it's an odd number. 1 here is an odd number, it's not balanced. What about here? Balanced. What about here? Unbalanced. But now something strange happens. The mysterious guy does not go for balanced, he goes for unbalanced. Right? So some break in the strategy seems to happen at this point in time. And then once you're in the 1 card per row, everything kind of predetermined, right? They just take turns, and he wins. Okay, so why is there this break in strategy? Well, there's actually, or what would happen actually if we just followed our strategy? Always go for the balanced position, always go for a balanced position. If we just continue, or if the guy just continued like this. Well, let's just have a look. So we're here, the clueless guy just has taken his card. Now if we go for balanced, what do? Well, we just take away those, 3 cards, right? And then we're balanced. Now the clueless guy has to take away 1 card, forced, and well, we are left with 1 card and we take the last card, which makes us lose. But there's another version of the game which says, well, if you have the last card, if you take the last card, then you win, right? So they're playing the version where whoever takes the last card loses. But there's the other version, which is actually the kind of the default version, which says if you take the last card, you win. Okay, and to win the default version, you actually always go for the balanced position, and you can always go for the balanced position, right? So once you're unbalanced, the other person automatically unbalances whatever they do. Then you can balance again, the other person unbalances, and so on, all the way to the end, and the end is balanced, obviously, because there's nothing left over, right? There's all even numbers, 0, 0, 0, 0. So it's going to work if what I just said is true, right? That you can always achieve a balanced position when you're in unbalanced, and that once you're unbalanced and you do anything, you actually get to something unbalanced. All right, so let's just have a look at strategy. Okay. So we're now really dealing with the game as it's played in the movie, okay? So, what's special about this position where he kind of changes strategy? Well, what's special about it is that this is the first position where there's, in every row, just either one card or just one of the rows has more than one card, okay? In all the other positions that we've seen previously, there's at least 2 rows that have more than one card. So here is the first position where there's just one row that has more than one card. Okay, then what do you do? What do you do? Well, it depends on how much is left over. So I've just indicated it like this, okay? So we can actually think our way through this now. Let's say there's like 3 rows left over and one has 3 cards, like just like what we've got here, okay? Then you can think, well, what can you do next? There's not that many things you can do. You could take away one of those cards, like the red card. Well, if I, as the mysterious guy, take away the red card, okay, what does the other guy do? Well, he takes away all of those, and then I'm stuck with the green card. So taking away the red card or the green card is not a good idea. So what else can I do? Well, I can take away some of these purple cards. If I take away all of them, well, then the other guy takes away the green, I'm stuck with this. So what I do is I just take away 2, right? So I just take away 2 of those cards, and then clueless guy, me, clueless guy has to take the last card, okay? So you're basically just aiming for clueless guy having an odd number of single cards in front of him when he starts. What about here? Well, similar sort of analysis. In this case, we're just taking away all 3 cards down there, and that leaves us in the same situation, okay? So pretty obvious that that would work. All right.
Et si c'était à vous de jouer les premiers?
So, okay, so in this, I mean, finally he kind of figured out, well, maybe it's got something to do, the clueless guy figured out that maybe it's got something to do that I always have to start, right? And of course, it's absolutely right. So now he says, what if you start? What if you mysterious guy start, right? Well, let's see, okay? So here I've got the complete game that they're about to play. So the mysterious guy has to make the first move, right? And when he's finished, he's necessarily in an unbalanced position, okay? And you can see it, right? So this is, after he takes like a card, he is in an unbalanced position because we've got 3 1s here, right? So it's unbalanced. Then what does the clueless guy do? Well, it seems like he's not so clueless because when he's finished with his move, he's actually in a balanced position. So maybe he's figured it out, right? So then, well, mysterious guy has to make a move, and obviously, he's to be in an unbalanced position. He is in an unbalanced position. There's this 1 here. Then what's the clueless guy do? He messed up. Have a look. There's 2 here, 1 here, 2 here, unbalanced, right? Which means that this guy can now get into balanced position. You see, he's in the balance, and now everything's won or lost, depending on whose perspective you assume. Okay, so, well, you know what the strategy is. I should tell you a little bit about why it works. Well, why does it work? Well, it's really about 2 things, right? I said it before. I claimed that if you're in a balanced position and you make any of those moves that are possible, you automatically end up with something unbalanced, okay? And that's actually fairly easy to see. So if you're unbalanced and say you're faced with this row and you take away anything there, right? Then you're not going to see, when you're finished and kind of redistribute things, you're not going to see the same thing again, right? Which means that one of these is missing, right? One of the ones that you see here, either the 1 or the 2 or the 4 is missing. One of them is missing, the whole thing is unbalanced. You can forget about it, right? Okay, so that's easy to see. Balanced, you take anything, you end up with unbalanced. The other way around is a bit more tricky. So to see that if you've got something unbalanced, you can always balance it, that's a little bit more tricky to see. And I just want to show you how that works. But to really be able to show you a really good example is I have to let you in on another secret, which is you can actually play this game with any numbers whatsoever. It doesn't have to be 1, 3, 5, 7. You could have chosen 666, 650, 3, 20, right? So you could have like 4 piles. and you draw the diagrams. You can play exactly the same game. If you want to be the one who has the last card, you just play always for balanced position. If you want the other person to have the last card, then you break your strategy as soon as you're faced with a position where there's just one row which has more than one card. Okay, so straight away. Okay, let's just have a look at one of those bigger games. So there's a bigger game. At the moment we are unbalanced. Okay, so we don't only have 1, 2, 4. We also have 8, the next power of 2 up. Okay, so here we've got 4 of those. That's balanced, balanced. That's unbalanced. That's unbalanced. So the largest power of 2 that's unbalanced is actually the 8. And we could use any of the rows that have an 8 in it to now balance this position. So let's just choose one. Let's just go for this one. Okay? All right. So focus on this guy first. We'll throw away everything else. So we're definitely going to take that card away. Okay? And what we're also going to do is we're going to take one of the cards from the 8. And then there's 7 left over. And when you actually distribute the 7, 7 is just 1 plus 2 plus 4. So we can distribute them over here. And then, well, this one was unbalanced because we just moved our cards. This is balanced now, it's 2. And since we've got like 1 and 2 and 4 in those positions, we can now check which is balanced. This is balanced. This is unbalanced, so we just remove the 2. This is balanced. This is balanced. We're finished. Okay, just one more example. Here's another setup. So it's also somehow unbalanced. It's balanced, balanced, unbalanced, balanced. Okay, so this time the largest unbalanced corresponds to the 4. Okay, so we leave the 8 and everything else that might be there on the left side, you know, we leave that in peace. It really depends on the largest one that's not balanced. So in this case, it's the 4. And we could use any of the piles that have a 4 in it to now achieve a balance. So let's just use this one here. Okay, so as I said, we're going to leave this in peace for the moment. We're going to leave this in peace. We're going to get rid of everything to the right. So get rid of it. Now, we're also going to get rid of one of the cards here. What's left is 3. 3 is 2 plus 1. So we kind of shift it over here. All right. Now, because we just shifted stuff from here to there, that column is balanced now. And now since we have a 2 in here and a 1 in here, we just have to check, well, 1 and 1, balanced. 2 and 2, balanced. So we actually don't have to do anything else, right? So if there was, say, this one wasn't there, we could just get rid of this one here, and then things would be balanced. Or if that one was missing, we could get rid of this one here. Or if neither this one or that one was there, we could get rid of both of them, we could balance again. Right? And that's basically it. Except what the movie is really about is, of course, to get the woman. And, well, even the woman gets into playing the game. So there she is, pondering the game. Wait, coming up. There she is. So it's actually a clueless guy who's really interested in her. All right. So let's just play a game with her. Right? You know how to play the game, so let's just play the game with her. Here we go. She has the first move, okay? So she has the first move. She's thinking, and she takes away 2 cards. Okay, now we're going to turn this whole thing into one of our binary diagrams. So there, she's waiting for us to move. So what is it now? We've got 4 here, we've got unbalanced here, we've got 2 4s there. Obviously, we just take away these 2 here and we're balanced. Huh? Okay, so back, take away 2 red cards and we're balanced. Okay, now she has to make a move. Thinking, she takes away 1, 2, 3, 4. And actually, well, we are in one of those situations where the strategy breaks, right? So we have to figure out, well, at this point in time, here we have to figure out whether we want to win or whether we want to lose, right? Well, I hate losing, so I'm going to go for a win, right? So what I'm going to do is I'm going to take away like everybody here in this row, and that leaves us with a winning situation, odd number of single cards. So let's have a look. So these things again. Now she doesn't have a choice, she has to take this. I take that, and she's left with the last card. And now depends, right? Is she impressed by my strategy, or does she hate me because I just won? Well, we'll see. You have to watch the movie to find out what happened in the movie.